Hi everyone. Welcome to Intro to Trig Ratios Part 3. Here's today's FLT. Given a right triangle, I will be able to set up trig ratios in simplest radical form. In Part 2, we talked about how to set up trig ratios. Today, we'll focus on trig ratios that involve radicals. So let's just do a quick review of rationalizing the denominator. Let's say we have 5 over radical 3. We don't want a radical in the denominator, so we have to rationalize the denominator by bringing the entire radical to the numerator. So we bring up the radical 3, and then we put this over the radicand, the number inside the radical, which is 3. So 5 over radical 3 becomes 5 times radical 3 over 3 because we want to always rationalize the denominator. Now what happens if we have something like 10 over radical 20? Let's rationalize the denominator. So we want radical 20 to move to the numerator. So 10 times radical 20 over 20, the radicand. But I can actually simplify this a little more. Notice how radical 20 can break down to the radical of 4 times 5. So we're simplifying the radical here. Okay, so this will break apart and it becomes 10 times radical 4, so we're separating the radicals, times radical 5, all over 20. And I know that radical 4 equals 2. So I can still continue to simplify this. 10 times 2 times radical 5, still over 20. And I know that 10 times 2 equals 20, so we have 20 times radical 5 over 20, but we can cancel out the 20 both in the numerator and denominator to simplify to radical 5. So this was just a quick review about how to rationalize the denominator so that we have a better idea of how to set up trig ratios and write them in simplest radical form. In Part 2, we learned the acronym SOHCAHTOA. It's a way to remember trig ratios. So let's say we have a right triangle and we're standing at angle theta. The hypotenuse is across from the right angle. The opposite side is across from where we're standing, and the adjacent side is right next to us. To set up trig ratios, we use the acronym SOHCAHTOA. Sine of theta is the opposite side over the hypotenuse. Cosine of theta equals the adjacent side over the hypotenuse, and tangent of theta equals the opposite side over the adjacent side. You might learn more about trig ratios in future math classes, but for now, I just wanted to introduce the topic. For our first example, we're going to find sine of angle A in simplest radical form. So as usual, we're going to start off by identifying the 3 different sides. We're going to be standing at angle A. So remember, for trig ratios, it depends on which angle you're standing at. So let's identify the different sides. This side is my hypotenuse since it's across from the right angle. And then side BC is my opposite side since it's across from where I'm standing. And lastly, side AC or side CA is my adjacent side since I'm standing right next to it. So now let's find sine of A using the idea of SOHCAHTOA. So here we're just focusing on the first part of SOHCAHTOA. Sine of A equals the opposite side over the hypotenuse. In other words, sine of A equals 3 over radical 10. But remember, we want to rationalize the denominator. So instead of 3 over radical 10, we get 3 times radical 10 over 10. So sine of A equals 3 times radical 10 over 10. This is written in simplest radical form. For example 2, we're going to find cosine of B in simplest radical form. So I will be standing at angle B, and remember to write down this triangle in your notebook as well. So this side is our hypotenuse, and we have our opposite side across from us, and also our adjacent side next to us. So this side is our adjacent side. And using the acronym SOHCAHTOA, we're going to set up the trig ratio for cosine of B. Okay, so cosine of B equals the adjacent side over the hypotenuse. For this problem, that's going to be 5 over radical 61. But remember, you want to rationalize the denominator. So this becomes 5 times radical 61 over 61. We cannot simplify the radical 61, so this value is cosine of B in simplest radical form. Let's look at one last example. We're going to find tangent of A in simplest radical form. So we're standing at angle A, and we're going to find tangent of A. Go ahead and identify the hypotenuse, the opposite side, and the adjacent side on your own, and then press play when you're ready to compare answers. So we've identified the hypotenuse, the opposite side, and the adjacent side. And once again, we'll use SOHCAHTOA to find tangent of A. So tangent of A equals the opposite side over the adjacent side. That's going to be, in this case, 5 over radical 75. We want to rationalize the denominator, so we get 5 times radical 75 over 75. But this is not in simplest radical form because I can actually still simplify radical 75. So radical 75 breaks down to radical 25 times 3. And so let's separate these. We have 5 times radical 25 times radical 3 over 75. And then radical 25, that's the square root of 25, so that equals 5. So we have 5 times 5 times radical 3 over 75. And we know that 5 times 5 equals 25, so we can further simplify this. 25 times radical 3 over 75. And let's simplify this fraction by dividing both the numerator and denominator by the greatest common factor, 25. We're left with radical 3 over 75 divided by 25, which is 3. So here in this example, we had a lot more steps, but just take your time, break down the problem, and go through it step by step. Remember to rationalize the denominator if there's a radical in the denominator, and to simplify as much as you can. So when you're setting up trig ratios, remember the acronym SOHCAHTOA. S stands for sine, C for cosine, T for tangent. And A stands for the adjacent side, O for the opposite side, and H for the hypotenuse. When writing answers in simplest radical form, make sure to rationalize the denominator and simplify any radicals if needed. And sometimes you might have to simplify the entire fraction itself. Awesome job today, and please remember to submit your notes on Canvas. Thank you.